let's take a look at how to solve rational equations. So rational equations are equations that have fractions involved, specifically with x's in a denominator, typically. Let's go ahead and look at number 19 to start out with. One of the strategies here is going to be to get rid of the denominators, and this is going to be helpful it's going to make it a lot easier to solve if we can get rid of the denominators. Before we do that, though, at times it'll be helpful to factor the denominator. If you look at this expression here, the x squared plus 2x, you see we could factor that as x times the quantity x plus 2. This is helpful. What we can now do is take the original equation here, and we can multiply both sides of the equation by the greatest common denominator. Sorry, the least common denominator. In this case, x times x plus 2. Let me show you what happens when we multiply times x plus 2. Okay? On this side, we need to distribute it to this fraction. We distribute here, and we distribute here. So what that ends up looking like is 3x times x plus 2 all over x plus 2 plus 6 times x plus 2 all over x equals 12 times x plus 2 all over, and remember we could factor the denominator there, x times x plus 2. Now you'll notice when we did this, because I multiplied by the least common denominator, these divide out. This is really nice because now I have a lot simpler of an equation to work with. I have 3x squared plus distribute my 6x plus 12 equals 12. From here we can solve using the methods we learned in the previous section. Here I'm going to subtract 12 from both sides. That gives me 3x squared plus 6x equals 0. I can now factor a common factor out of this. I get x plus 2 equals 0. And now I can solve. I know that x can be 0 or x plus 2 can be 0 to give me a solution. That means that x equals 0 or negative 2. Now, we do have one issue here that we have to check. These are my solutions, but remember my original equation here. My original equation is set up as a fraction, so we need to check and see, are these numbers in the domain? In other words, can I plug these in and get a correct answer? What you'll notice is when I plug 0 in, that's going to cause a problem here, isn't it? I can't divide by 0. So that tells me that 0 is not a solution. What about negative 2? You see we have the same issue here. Negative 2 is not a solution either. And so this equation has no solutions. Okay. All right. So the general strategy is the same, and often you will have equations that work. All right, so general strategy, if you need to, factor the denominators so you can see what the least common denominator is, then multiply each side of the equation by the least common denominator. That will help you to get an equation that you could solve, and then go ahead and use one of the strategies for solving. Once you have your solutions, check them and make sure they do work. All right, let's take a look at number 86. Solve for t. It means we want to get t by itself. It almost looks like it's by itself, but it's 1 divided by t. We don't want 1 divided by t, we just want t. So our strategy is going to be the same. You see we have a t, an a, and a b. That means I'm going to multiply each side by t, a, and b. Multiply both sides by t, a, and b. Alright, so when I do that, I now have TAB over T equals TAB over A plus TAB over B. I distributed here. We can then divide out since I'm multiplying here. And that leaves me with AB equals TB plus TA. Now you may be looking at this and saying, I don't know how to solve when there's two t's. Well, the trick is to make it one t. The way to do that is to factor out a t here. So you could see we have a t here and we have a t here. If I factor that t out, I'm now left with t times b plus a. I now have 1t times b plus a. If I divide both sides by b plus a, I get t is equal to ab over b plus a, or I'm going to switch it around, a plus b. And that's the video on solving rational equations. Go ahead and try example 1 and example 2 yourself. Pause the video here. Hopefully you were able to do those. Here are the solutions to example 1 and example 2.